Okay, so how can you tell if a function's even, odd, or neither? Well, graphing is certainly one way to do that. I encourage you, though, to start exploring an algebraic way to do that because you're going to run into functions that are not polynomials, that are not square roots, that are weird, and you got to be able to know how to do this. And it might not happen this course, but it will eventually. So the easiest thing to remember, the easiest way to do this algebraically is if a function's odd and you substitute a negative x in. So what about this? What about x cubed? If I substitute in positive 2 and this is x cubed, won't that give me an output of positive 8? And if I drop in a negative 2, won't that output be negative 8? So x cubed is an odd function. Now I've had people tell me, oh, all the exponents are odd, that makes it an odd function. Well, that's true. However, you've come across them here. I mean, what about this radical? What about this radical, and what about this rational expression? So, we need to kick it down the road a little further. And notice there is symmetry about the origin, right? So that's another thing. And so then what if I even function? Well, if I drop in negative x, nothing changes. Everything stays the same. My output's the same as my output is the same for both. So if, like x squared, notice the exponent is an even number, so that tells me it's an even function. If I drop in positive 2 into that, though, I get 4. If I drop in negative 2 into that, I also get 4. So yeah, it's definitely an even function. But you're going to come across things like, in fact, this course, you're going to come across, I'm going to ask you some things about the graph of cosine x, and well, it works out cosine's an even function, and you don't know why yet, and I don't want to go there yet, but that's why you need to be able to deal with this algebraically. So that is an an even function. I better write even next to it just so we have that written down. And then if it's neither one of these things are true. So basically, now let's backpedal. If all the signs change in a function when I drop in negative x, that tells me it's an odd function. If no signs change, that tells me it's exactly, my output's my same in both cases. So that's an even. And if only some, and if it's neither even nor odd, if not all, if some signs change. Some signs change, but not all. So let's go back and look at this. So f of x is 3 here. Let me get rid of that parentheses. I don't know why I wrote it there. 3x to the fourth equals f of x. So if I come in and I substitute in negative x every place I see an x, that's why I wrote the parentheses. When I raise a negative number to the fourth power, the negatives cancel out. Notice how my output is exactly the same as my original. That tells me this is an even function. And yes, because the exponent is 4, the only exponent is an even number. That's another way that's another flag, but that's not, it's like I said already, you got to find other ways to think about it. So then I have the square root of x. So what's f of the negative square root of x? Well, I can't take the square root of a negative number. This is neither even nor odd. Part of it's because negative numbers aren't in the domain. Okay. And then this 1 over, what's f of negative x equal to 1 over negative x plus 3 times negative x. 3, Dan. So 1 over negative x is negative 1 over x. And then 3 times negative x is negative 3x. See how all the signs change? It was positive, now it's negative. All are negative. So that means it's an odd function. So maybe hopefully this algebraic, I didn't spell neither right, did I? Oh, I did, I guess. Okay. So hopefully this algebraic way of looking things will help you out now and in the future.